All right, good morning everyone, and thanks for being here. So my name is Sander, and I have a confession to make. I like building monoliths. There, I said it. So it feels good to get this off my chest, and I have a feeling that there's more people in this room that feel the same way. Because nowadays, if you listen to talks at conferences, it's almost only about microservices, right? How to use them, where to use them, what technology to use them with. And it seems like there's no other architecture anymore than microservices. And I think that's a bad thing. Not because I think microservices are bad, but because I think a lot of people are adopting this microservices architecture without thinking it all the way through. And also without looking at some of the alternatives that are out there to actually have some of the same benefits as microservices without the overhead. So this talk will be about one of these alternatives, the modular application and modules. So a little bit about me. I work as a fellow and software architect at Luminous, which is a software technology company in the Netherlands. And at Luminous, we both develop products for ourselves as well as for customers as consultants. And during product development, something that you will find out is that you really want to have maintainable, extensible, reliable, etc. software. Because it's yours. You have to run it, you have to maintain it, not for just 1 year, not for 2 years, but for 5 or maybe 10 years. And in that space, in that product development space, we really turned to modules, module systems, and modularity as a principle to help us achieve that. So I have quite some experience in modular development stacks, and mainly in the Java world, OSGI up until now. And with, for example, Java 9, that has been released a few months ago, and we're already having Java 10, we also get a module system in Java. And we actually got so deep into that in the early access releases that I was asked to write a book about that for O'Reilly. And I've given a few, or more than a few, presentations about this Java module system already. And that won't be this talk, that's a different talk. But sometimes people come up to me after that and they say, okay, well, that's all very nice, Sander, it's a module system, but didn't you get the memo? We do microservices now, so why would we want to use this module stuff? So you can consider this talk to be my definitive answer to that question. Because I do think there's a place for modules and modularity besides microservices. Now, this talk has a question for a title. So it would be very unfair to keep you hanging until the end, until I give the answer. So, without further ado, here's the answer. Modules or microservices? Yes. And, of course, you're all developers, so you might have interpreted this as an exclusive or, but that's not the right way to look at this. The way to look at this is as alternatives and options. And I hope that after this talk, you will see the choice between modules or microservices not as a binary choice, but as a spectrum where you can mix and match to your specific situation. So the real answer to this question is, of course, it depends. So you can tell I'm a consultant, because this is always the answer, it depends. And in this talk, we'll look at some of the factors that play into this decision about when to go the microservices route and when to go an alternative route. So before we do that, before we dive into microservices and before we dive into module systems themselves, I think it's very important to talk about the principle of modularity itself, because this is really something that's key to understanding all of this. And for this, I want to take an example that's not software-based. So I took this picture. Well, actually, I wish I took this picture, but I've just found it on the internet and pasted it into the slides. But here we have the ISS, the International Space Station, which is a marvel of engineering. At least that's what I think, if I see this. And this is something that has been built over decades by many different teams, large teams, distributed across the world. And somehow it all got together in space, and it works. It's a single system that works out there. So why? How did this work? Because it's such a complex application, if you look at it from the outside. It's such a complex system. So I believe that one of the key principles here is modularity as well. Because what happened is that these teams around the world, they didn't just start doing their thing without thinking. No, they first defined their interface points between the different modules. And yes, this space station has modules as well. Some were built in Russia, some were built in the United States, by different people, different skill sets, different goals, different aims. But in the end, it all came together because they thought about how these modules could interconnect, how they could work together. And the nice thing is that the Americans, they could have completely different interiors in these modules. And they could have completely different aims and goals with the modules that they were constructing than, for example, the Russians. But in the end, because they had these interface points, because they had these interconnects that were well-defined, that were agreed upon upfront, this is something that works. Now, I think this doesn't just work for space stations. This also works for software. If we approach our software in the same way, then we'll have a much better time of creating maintainable, extensible, and reliable applications. So, as far as I'm concerned, modularity is the key principle in software architecture and in software development. So let's make this a bit more concrete if we look at software development, because, well, we talked a little bit about interfaces, interconnects, etc. There are 3 tenets of modularity that we should keep in mind when thinking about modular software development. The first one is all about strong encapsulation. And it may sound a bit counterintuitive that the first principle is all about being able to hide stuff. Because why would you want to hide stuff? We're all about openness, we're open source people, right? We want to know everything of everything. But that won't scale. That won't work in the real world when you build complex and large systems. You need to be able to say, okay, this is my private implementation details. You don't have to know how I do it. You just have to trust me that I can do it in this way, and that I will offer to you something that you can use without exactly having to know how it works. So strong encapsulation means hiding stuff, which is one of the foundations of modular software development. Now, obviously, if you hide everything, that won't be very useful, because then you will have components that actually cannot work together. So even though you have implementation details that you want to hide, on the flip side, you also want to have APIs, contracts, services definitions, whatever you want to call it, that are explicitly defined and that you share with the outside world. And this doesn't only apply to library development. This also applies to large applications that we're developing with different subcomponents. It's the same problem there. So these well-defined interfaces allow these modules that have strongly encapsulated parts to still work together in a useful way. Now last, if you actually apply these principles of creating modules that have encapsulated parts and that have publicly exported APIs, then you end up with an application that consists of lots of small parts. And you still need to bring this together into one big whole, like they did with the ISS space station. So, in practice, if you have these small parts, you don't want to combine these into a new system by hand or by sheer luck. You want to have some explicit description of how these parts fit together, and also something that can be checked, hopefully, by tools that will help you to see if you have an application that makes sense, that's complete. So these 3 tenets of modularity we'll see back in this presentation in different forms, because this doesn't say anything yet about what technology you're going to use to achieve this. But for us, modularity has become the ultimate agile tool, because if you have modules, if you have modular parts in your system, it means that you can easily replace internals, that you easily can replace implementations as long as you adhere to these well-defined interfaces. It means that you can have extensible and maintainable systems by seeing the impact of your changes, because you have explicit dependencies between all parts in your system. And there are lots more benefits that modularity brings us when looking at agile software development. Now, I think it's time to talk about microservices now. And just keep these principles about modularity that we saw in mind. There is no common agreed upon definition of a microservice, as far as I know. So for this talk, I'll just use this definition. We're going to say that a microservice is a piece of software, a software component that's independently deployable somehow, and it implements some kind of business capability. We're not talking about these little small technical services. No, these are domain services usually, like in the domain-driven design sense. And they do one thing and they do it well. That's the micro part, right? The crucial bit here is that these microservices interact with each other over a network. And again, this is not about the specific technology. This could be REST over HTTP, this could be gRPC, this could be queues and events. Doesn't really matter. There's some kind of network and distributed system going on with microservices. Now, what do we see here? Anyone want to take a guess? No? This is the microservices dev room at the FOSDEM conference in 2017. And people are excited about microservices, right? You can see that. It's packed. Wow. Well, we're going to fix that, because what I see is people looking in despair, right? What is this? What have I gotten myself into now? I see people praying for a better solution, right? This can't be it. Really? So, yeah, I think we all know that microservices are hard to pull off. That doesn't mean that they're a bad thing. It just means that it's incrementally harder than doing monolithic development. So, I think it's very important to reflect upon the question of when to use microservices and when not to use microservices. And that's a discussion that's, in my opinion, lacking in our industry at the moment. So, to help this discussion, I want to show you the alternative of modular software development. This doesn't mean that modular software development will replace all situations where microservices are now used. But I think, at least in a large percentage of the cases, it might be that you land somewhere on the spectrum between modules and microservices instead of going all the way to microservices from the get-go. So why do people move to microservices? A lot of times the reason you hear is that somehow their systems, their monoliths, have become too complex to manage, too complex to evolve. And they want to somehow manage this complexity by chopping it up into pieces, and microservices seems like a decent way to do so. And some of the other reasons are about scaling a system, being able to scale independent services, and resilience into your architecture, right? With microservices, you can have some independent failure modes, etc. Actually, if you think about it, this complexity management question that people have is actually a cry for modularity in disguise. And yes, putting a network boundary in between does force you to make your code base modular. But it's a really, really crude tool to do so. And we'll see that with other module systems, you can achieve some of the same benefits without the downsides. And we'll look at scaling and resilience later as well. So, what if we have a microservices system? We could have something like this. Forgive me the examples, I've been working on educational systems for a few years already. So we have a user service, we have assignments, we have students, we have grading, courses, attendance. That's all very well, right? And often people look at this and they say, oh, well, it's a very nice picture, it looks very comprehensible. And if this were a monolith, then it would probably look like this, right? Big bowl of spaghetti. So, like they say, undocumented code, spaghetti code, whatever. And of course, these code bases do exist in practice, but it's sort of a false equivalency that's going on here. And we'll see later that these monoliths can be structured really, really nicely as well. So what happens typically if people think about the messy monolith is that they start developing a system, and as time goes by, it becomes harder and harder to evolve this messy monolith, because you have all these implicit dependencies. You fix something here, it falls over there, and you have all these different parts that have far too much knowledge of the internals of different parts, so you can't really refactor anymore. People start to be afraid of touching the code. This all may sound familiar. So you hit a brick wall in terms of costs. And costs here is not just money, it's also about people being afraid to touch code bases, features taking longer and longer to be developed. So that's something that people want to counter with microservices. And yes, I do think that a microservices architecture does give you a path forward to create systems with more features that scale better in terms of additional costs. So this is definitely a concern that's valid. However, look at this gap. If you start your development with your simple monolith, I mean, there's essentially no cost, right? You just get a team together, you start coding, and features start flowing. Well, not so much if you go the microservices route. Because we all know microservices do bring a lot of additional complexity. So what kind of complexity? Well, for example, if you have all these services, there's this simple matter of, okay, how do we find each other? How do they actually work together? And for that, of course, there are all kinds of solutions. We have Console, you have Netflix Eureka, etcd, all kinds of tools that are really cool to learn and to start using, but that are also quite complex. And all of this is not something that's insurmountable, but yet again, if you have this complexity already from starting your development, it will mean that your features will start developing slower. So people think, okay, well this leads to some kind of service mesh technology, which is sort of upcoming now, Istio, and etc., etc. But also beware, this can turn into a service mess really quickly if you don't watch out. Now, what other concerns do you have? Well, obviously, we recognize that microservices communicate over a network, so we're prone to all the fallacies of the network that we've all read, I hope, at least. So the network is not reliable. The network is not fast. The network is not, well, and you know all these fallacies, right? So we need to code for this. We need to cope with this into our systems. And again, there are tools for that, like the Netflix Hystrix. You can do bulk heading, circuit breakers, and all this cool stuff. But again, this has nothing to do with your domain. This has nothing to do with your application. So, what else? Deployment. Well, that's a solved problem, right? Just put it in a Docker container. Problem solved. Or is it? Because we could also run on Mesos, for example. You could use maybe our Rocket containers instead of Docker. So again, here's a technology selection process going on, and there are lots of cool technologies to inspect. And then if you have Docker containers, you somehow need to run them somewhere, so you need to set up something like Kubernetes, or, well, there's many other tools. And this is not for the faint of heart. This is one of the reasons why there's such a gap that we saw between monolithic development costs and microservices development costs. And there's more, of course, because if we have these independent services, we can have multiple versions, maybe even multiple versions at once, which can be really hard to manage. So you get into configuration management tooling and deployment tooling and API management tooling. And yet again, this is something that you, as a company, as a developer, will have to get acquainted with, have to select, have to maintain, have to run. And probably you don't have to run it once, but you have to run it 4 times for your development, test, acceptance, production environments. And of course, there are cloud providers that try to help you with this and to make this easier for you, but still you need to understand the underlying issues here, because API management and configuration management, even with the best tooling, is also conceptually hard to do. It's not about only technology, it's about running concurrent versions, etc., which really leads to an explosion of issues that you can encounter at runtime. Now, there's also the security angle. If you go from this monolithic web application, which was fairly easy to secure, you're going to services that interact now, and do you delegate permissions, or do you have a trusted subnetwork, or do you do any of the other best practices? Again, lots and lots new stuff here to learn and to apply. So, I'm not trying to say, again, that microservices are bad. I'm just trying to convey what it means to do microservices development in an honest way. Because we've seen so many technologies and issues already now that don't have anything to do with the actual domain problem that we're solving, right? And yes, I also think that some of these problems are really cool and challenging. But the question is, when should we take these problems on, and why? And if you look at this, I mean, is this architecture? Is this software architecture? Like I said, this has had nothing to do with our domain. This is more like archi-torture, if you think about it. And this is really something that you would only want to do if you really need to, in my opinion, and not because it's cool and people are trying to push it onto you. So we've seen where this gap comes from when you start development in either a monolith or in the microservices way. And I said previously, there are lots of vendors and cloud vendors that really try to minimize this gap. And they're doing an okay job, I think, if you at least look only in terms of money. But adopting these vendors still won't magically transform your organization into an engineering organization that really understands and lives through all these issues and challenges that we just saw. So really, here's still something in terms of human costs, in terms of knowledge, that needs to be bridged. So what about modules? How do they stack up to this microservices architecture? And before we do sort of a comparison, I just want to take you on a journey through module systems in different technology stacks to show you that they do solve similar problems in a way that really adheres to the principles that we saw previously. So again, we have here our microservices architecture, and where previously we saw this messy monolith on the other side. Surprise, surprise, we can also turn this into a single application that has the exact same structure as our microservices architecture. Only now we don't have distributed components. No, we have modules. We have strong module boundaries inside of this modular application. And really, what happens here is that we take the same design approach, but instead of slapping a network in between, we take a module system that helps us enforce these module boundaries. And that helps us make the same decisions as to where the boundaries are in our domain without incurring all the complexities that we just saw previously. Now this gives us a third way, which is, I believe, an intermediate between microservices all the way and this messy monolith where you hit a brick wall after maybe 2-3 years of development. So with this modular app approach, we still have a little upfront cost because you need to know about the module system and the modularity principles, and you need to apply them in your stack of choice. But still, it's hugely less complex in terms of runtime complexity and in terms of different problems that you're solving that are, in my opinion, often accidental rather than really meaningful. So people hear me talking about modules often and about the principles, encapsulation, well-defined interfaces, explicit dependencies. And they say, okay, so well, there's sort of like objects because, well, for example, in Java, you have private fields and you have public stuff. And, well, yeah, that's close. That's the right way to think about it. But modules live at a higher level of abstraction than classes and objects. But the principles are actually very much the same. So what does this look like in the current languages that we have? So in Java, like I said, we used to have OSGI as a module system that was a third-party module system, which was fairly popular with a few big players like Eclipse and other application server vendors, etc., but didn't really become mainstream. And as of Java 9, there's now a module system in Java itself that can help us create modules with strong encapsulation and explicit dependencies. Now, in the JavaScript world, well, it's the JavaScript world, right? So there were like dozens of different module systems that you could choose between. But lately, in the ES 2015 standard, they actually got a native module system in JavaScript as well, which I think is a very good thing. And we really start reaping the benefits from that as well. What about, for example, C++? Well, we'll see that even in C++, they're already thinking about a module system that will most likely be in the C++ 20 spec. And in .NET, you can achieve similar situations if you use NuGet packages and assemblies that are well-defined. If you look at what happens, for example, in .NET Core, you see that it's also all about creating small and a modular platform. So I think all these languages and all these technology stacks are moving toward a more modular feature by applying these principles and by allowing developers to apply these principles for their own applications as well. So let's look at some of these module systems. For example, in Java, we can now define modules. So for a jar file, we can now say, this is not just a jar file, but it's a module. And this module exports something, in this case, the attendance API package. So you export packages in modules in Java. But we can also express that this module, this jar file, has a dependency, for example, on the students module and the courses module. And this is something that the compiler will help us enforce. This is something that even at runtime will be available as information for the module system to do module resolution and to do to guard strong encapsulation. Because what happens in a module is that unless you export a package, it's strongly encapsulated. So this allows you to really hide your implementation details. So any packages and any types in these packages that are not exported, you can freely refactor, you can change them without breaking any of the other modules. The well-defined interface is, of course, defined by whatever types are in your API package that you export. So only these types can be used by other modules if they have a dependency on your module. And these explicit dependencies, like I already said, they are used by the Java module system to ensure that you have a correct set of modules that have all their dependencies satisfied, which is a huge step up from the previous class path that we had in Java, where you just slap on a few jar files and hope for the best, because there might be a jar file missing, there might be a duplicate jar files, and you only find out at runtime with class not found exceptions or any of these other nasty exceptions. And even the Java platform itself has been modularized using the same module system. So what you see here is a small subset of the modules that are in the JDK. And it already shows that this makes the JDK a little bit more understandable, rather than having this big single rt.jar file containing all tens of thousands of classes that make up the JDK and the Java library. You can now see that we have these nice little modules with their own responsibilities, with their own APIs, and they even have these explicit relations that we can put into a chart here. Now, looking at JavaScript. Like I said, in ES 2015, it got a module system. And there, we can also see that we can export a function, like the square function here. And we can also still have functions that are internal to the module. So like the function secret here is used, but it's not exported. And then in another JavaScript source file, we can say, okay, I want to import, for example, this SQ function from my module, and then we can actually use it from this other module. Now, again, looking at the principles here, we have a form of strong encapsulation, because previously everything would be in the global scope in JavaScript, but now with modules, this function secret is not accessible from outside of the module, which is really helpful, of course, to protect your internals. We even have some sort of well-defined interface for this module, because we export this function SQ and nothing else. And the explicit dependencies are made up by these imports between modules in the JavaScript source files. So of course, when you think about it, JavaScript is not strongly typed. So if you really want to have well-defined interfaces, consider using TypeScript. But still, it shows that JavaScript has made great steps in terms of modular development. I've heard there was also something like CSS modules, but, well, let's not go there. Last, I want to show you, this is preliminary, but it's still under discussion for C++, but there's the same way of approaching modular coding there, where you have, in this case, a module called myModule again. We export the SQ function, we have an internal secret function, and rather than including header files, we're going to import these modules, and even a module like standard.io, and we can use this square function because it's exported, but we cannot use this secret function because it's strongly encapsulated. And this is the well-defined interface, and here's the explicit dependencies. So I hope you see the pattern here. These principles are starting to appear in many technology stacks, and I think we should start using them. Modules are everywhere, and remember, these principles are now applied above the level of objects, but below the level of complete applications. And the good thing is that we already used to be able to create these nice whiteboard pictures of our applications, and we're now able to translate these into actual compiler and runtime enforced module boundaries. So all these encapsulated details can now be truly encapsulated, and it doesn't require any discipline anymore to enforce this. No, we can just rely on, for example, the C++ compiler or the Java compiler to help us enforce these module boundaries. So it's a really great way to actually translate whatever we came up with on the whiteboard into a real working piece of software. So let's get back to the question, because we now have seen microservices, their complexities. We've seen some module systems and how they help us in applying these modular principles. So what kind of trade-offs are they, and how would you go about that? So again, these were some of the main drivers for people to start adopting microservices. And I would say if your reason to go to microservices is to be more modular, to manage the complexity of your application, then I think it's fairly safe to say that using a module system in your favorite technology stack is also a very, very good alternative to this, because you prevent a lot of complexity from going into your architecture. But it still leaves, of course, the question of, okay, but what about the scaling reasons or the resilience reasons to go to microservices? And these are valid reasons in some cases to go this route. So what are some of the advantages of microservices over this modular application development approach? Well, one of the advantages that we haven't talked about yet is that if you go the microservices way, then you can actually choose the best stack for each service that you're implementing. So in our example, you might implement the learning material service in Node.js, you might implement the student service in Java and assignments in Python, etc. No big problem. And even though this is possible, you should ask yourself the question, is this something that I want inside of my company? Is this something that my company is ready for? Are you ready to maintain 1, 2, 3, 5, 10 different technology stacks? I mean, where's the limit? And the question, I mean, is really context dependent, of course. But in a lot of cases, it just makes sense to go with one technology that you all know well and start using that. So this reason, while valid in some cases, really depends on your context. Another advantage of microservices is this independent deployability of services, right? Again, here we have the learning material students assignment version, services, and we can deploy different versions on different release cadences from different teams. And this is quite a compelling reason to go with microservices. On the other hand, what I see a lot of as well in practice is that this isn't really possible. Because, well, yes, the learning material service uses the student service, and the student service uses the learning material service, so they can't be really independently deployed. They need to go together. Oh, and assignments needs to depend on version 3. And, well, what you actually get here is a distributed monolith. And I think that that's even worse than a monolithic modularized application. So even though the promise of independent deployments really is alluring, it's kind of hard to pull off in practice, and it really takes a new way of thinking about dependencies between your microservices. So it's possible, but in practice I see a lot of situations where this just somehow devolves into, okay, we'll just roll out all our 5 or 10 or 20 services together every, well, whatever increment you do. So related to this, if you have these independent running deployments, it's also that you can have independent failure. So if our assignment service goes down, then it doesn't necessarily have to reflect on our whole application, because maybe the learning material and the student service can still keep on serving. But again, this only holds if your services are truly autonomous. Because if we had these dependencies that we just saw on the previous slide, then each of these services would fall over because they rely on the failing assignment service. And again, this is not impossible to solve, but creating truly autonomous services isn't something that you can easily do when you come from the more monolithic mindset. You need to think about more event-based integration. You need to think about fallbacks. You need to think about all kinds of things that weren't actually an issue in your previous situation. So if you want to have this advantage, then your services need to be truly autonomous. That's the sort of takeaway here. Now, another one that has to do with the independent deployment is the fact that we can scale independently. So what if, for example, our learning material service does some heavy lifting with graphics? So we could, for example, deploy it to some very hefty graphics instances in Amazon. And maybe our student service is moderately trafficked, so we deploy it on 2 medium instances. And our assignment service is barely used, so we just deploy it on some micro instance. And this is a really nice way of scaling if you have microservices. So if you have this issue, if you have different components that have truly different scaling needs, then yes, extracting them into a microservice makes total sense. However, it's not as if you cannot scale a modular monolithic application. Only the fact there is that you scale uniformly. So a lot of modular applications that we develop, we just deploy them to Amazon as well, with multiple instances as well, but you have the whole modular code base running on these instances. And in our case, most services don't really have these really different scaling profiles that I showed previously. So this works pretty well when we just put a load balancer in front and have these modular applications scaled in full. So again, this is not an either-or, it's just a trade-off. If you look at some of the advantages of modular applications, of modular monolithic applications, then yes, we of course have something that's easier to deploy, because once we've built the application and all the modules have come together, we have a single deployment unit that we can deploy. Whether we do that on the cloud or bare metal, doesn't really matter. But this is something that we can do in much the same way that we did previously as well. Another advantage of modules is that it's really helpful to have compiler support if you want to refactor across module boundaries. So what usually happens if you go the microservices route is that you think really hard up front about the service boundaries, and then once it's in place and in production and deployed, well, you better have a very good reason to change these module boundaries, because it's a lot of hard work, right? It's coordinating between different teams, different code bases, it's hard. And how hard it is proven by this picture I took from a Uber presentation. And it's interesting, what happened there is they started from a monolithic situation, where in 2014 they said, okay, we're going to do services, and then somewhere in 2016 they ended up with 1,800 microservices. Well, I mean, it's a ride-sharing app. I don't think there are 1,800 independent business functionalities. And that's also something that was acknowledged by Matt Rennie, one of the Uber leads who gave this presentation. And he said, okay, so what really happened here is that teams started creating services, and then they needed another service, which was already sort of in place, but didn't really match the requirements of the other team. And then they had two choices. Either they had to go negotiate with the other team to change the other service, and then to wait until it was finished and prioritize and just play politics, at least. Or they could just sort of clone the service, tweak and match it to their own requirements, and deploy it and run it themselves. And, well, guess what happens? People take the path of least resistance, and that's how you end up with 1,800 microservices, which I don't really think is something that you should strive for. Now, another advantage of the modular application is that we're talking about strongly typed in-process communication, rather than the weakly or JSON-typed interaction between network applications, with the benefits excuse me, of having, of course, virtually no or less serialization overhead or network latency. And really, there's a lot of boilerplate going on in many of the microservices applications that I've seen. You prevent that by going the modular route. And have you ever tried serializing a function? If you do sort of functional programming, it's really hard. So doing microservices also sort of constrains the types of APIs that you have between the implementations in your system. So if you do go the microservices route, really consider, instead of doing sort of untyped REST, also to explore, for example, something like Avro or protocol buffers, to have a more tooling-supported way of evolution and communication in your APIs. The other thing here is that strongly typed in-process communication also entails synchronous communication. And if you have truly autonomous microservices, then you'll find out that lots of work that's happening inside of your application and services will become async. And fortunately, we have lots of very nice libraries to help us with that, like RxJava or all of the other reactive stuff. But still, it's harder to reason about and maintain than the more synchronous way of interaction that you can do in a modular monolith. Now, that doesn't mean that everything has to be synchronous inside of a modular application. I mean, you can still apply eventual consistency, for example, between different parts if that fits your domain, if that fits your problem. But it's a choice that you can make, and it's not something that's forced upon you by the physical architecture that you've chosen. In any case, whether you're doing modular development or microservices development, it's still always a good idea to partition your data. And with that, I mean, you often see that people advocate that microservices should own their data, and I think the same applies to modules inside of a modular application. A module should be responsible for a part of the data, and it shouldn't be sharing this internal schema with other modules. So this is something that can go both ways. Now, having these nice explicit dependencies between the modules in our modular application means that we have less possibilities for runtime failures, because we can statically check that our set of modules is actually correct and is actually something that will work as an application. Whereas if we have the dynamic service discovery in our service mesh or service mess, then we do have the issue of services not being able to reach at runtime, and you have just different failure modes going on there. So I think it's time to wrap up and sort of make up the balance. And I want to do this by looking at this tweet. And there's this guy who watched a presentation from Jonas Bonner at Lightband. It was a really great presentation about reactive microservices. And he had this sort of epiphany, right? He said, okay, well, like moving from a monolithic to a microservices architecture is like a bit like going from classical to quantum mechanics. Finally, something that matches reality. And to which I say, okay, well, yeah, we had this quantum relativity, etc., that was discovered by Einstein, which really taught us that at the speed of light, everything changes. But the question you should ask yourself is, are you really at the speed of light? Are you really at the limits of everything? Because for all the rest, we still have our Newton, who just gives us classical mechanics and say, okay, chill out, the apple still doesn't fall far from the tree. So what we're doing here is you don't want to solve problems that you don't have. You don't want to bring additional problems into your architecture if you don't need to. And this is really something that has to do with scale. And what kind of organization are you? And you're most likely not a Uber or Netflix. At least most systems that I build are not at this scale. And I think if we're looking at this honestly, it's really a long tail of systems and organizations that do not have these immense scaling needs and these immense problems that Uber or Netflix face. So be realistic about your own situation and about your needs, and try to figure out whether you're doing microservices just for the management and the modularity aspect, or if you truly need some of the operational aspects as well. Because I think, well, like the 80% of us are really somewhere there. And I'm going to leave you with some wise words from Socrates as well. I found it on Twitter, and he said to us, okay, like, you know, Kubernetes is an ancient Greek word, meaning more containers than customers, right? So this is really something that I think happens in our industry. We start jumping on new technology and start using it because it's cool, but in the end, you should only use it because you need it, and you need to find out why you need it, when you need it, and how you need it. So what do? You solve the problems you do have in the simplest possible way, as far as I'm concerned. And that means, in this case, that I think you owe it to yourself to at least read up on whatever is happening in your favorite technology stack in terms of modular development. So you have this alternative available to you if you want to. And besides, it's never bad to know about, for example, strong encapsulation, well-defined interfaces, explicit dependencies. These are all timeless and technology-agnostic principles that can help you create better software, create more maintainable software, and extensible software. So, what would be my advice to you? I would say, from the start, design your system as if it were a microservices system. So, do think about the boundaries in your domain. Do make nicely decomposed components in your system. But don't start building them as microservices yet. Pick your favorite technology stack that has the principles of modularity in terms of a module system, and start building the system as modules. And if you need some of the other benefits that we talked about from microservices, you can always yank out one of these pieces and start using them later as an independent service. because you've already done the hard part, which is decomposing your domain into these nice modules with these sane module boundaries. And in the beginning, if you do this in a modular application, you still have some leeway to refactor across these modular boundaries, like I talked about. And then once you're confident that you're there and that you need the scaling needs, that you need the independent failure modes or the independent deployment for some part of your service, then you can just pull out the service and start treating it as a microservice. And the question also is, should a service always be micro? If you have this modular approach, maybe you can have more coarse-grained services as well. And this also decreases, of course, your operational burden. And don't worry, I mean, you can still do all the buzzwords. You can do reactive, NoSQL, cloud, DevOps, domain-driven design. I know these are often sold as a package deal with microservices, but really, that doesn't have to be the way. You can just as well apply these principles in a modular, monolithic application. So if there's one thing that you take away from this talk, I hope it is this picture, where we can easily see that we don't want to end up in this messy monolith situation. I fully admit that has happened to a lot of us, to me as well in the past, and that's something that we just don't want, right? But solving this by fully going all in on microservices is really something that isn't just up to you as a technologist, because it brings so much other costs with it as well. And in that sense, you owe it to yourself to also explore the modular application alternative. And I hope you've had enough information to start looking into that now. So with that, I would like to thank you all for attending this talk. If you really like to read more about this, then I encourage you, if you're in the Java space, to go to javamodularity.com, where you'll find more info about the book I've written together with Paul Bakker. The bit.ly link I've shown here is an O'Reilly article that I wrote last year, which details all the arguments that we talked about here as well. So if you want to share that with a colleague, then please do so. And I also have some Pluralsight content. If you're interested in that, check it out. If you don't have a subscription, come up to me. I'll give you a free month. And with that, if you have any questions, feel free to come up after the talk, and I'll be here all day and tomorrow as well. And I'd really like to chat with you about your thoughts about modules or microservices. So, thank you.